This is question 22 on chemistry from the 2014 BMAT. So we're told that this material, graphene, is composed of a one-atom thick layer of carbon atoms arranged in tightly bound hexagons. And so based on this information about its structure, which of these properties would we predict? That's a high melting point, that it's a good conductor of electricity, or that it's water soluble. So here's our picture of graphene with the carbon atoms in these hexagons. So let's look at these properties. So firstly, would it have a high melting point? Well, think about what sort of bonding is going on here. So we know carbon generally forms covalent bonds, for example in diamond and graphite. So we imagine that's the same in this graphene. So if all these bonds are covalent, then we know these are going to be very strong. And what will that mean for the melting point? It's going to be very high because we'll have to overcome these covalent bonds in order to liquefy the substance. So this one's correct. Next, we're told that it's a good conductor of electricity. Would this be the case? Well, think about graphite, which is similar in structure to this graphene, but this is just maybe one of the layers of graphite. And so what we know about graphite is that each carbon has 4 electrons, and it uses 3 of them in these 3 bonds around it, and one of the remaining electrons is left in between the layers, and these are free to conduct electricity. And so we imagine with graphene, this is going to be a fairly similar process with 1 delocalized electron per carbon. And in fact, we can look at this as like lots of benzene rings joined together with these delocalized electrons, but they can delocalize across the whole molecule. So we imagine this is a good conductor of electricity. And finally, would it be water soluble? Well, going back to what we said for point 1, these are tight covalent bonds, and in order to dissolve it in water, we'll have to break them because this is a giant molecule. So this isn't going to be very soluble in water because we'd have to overcome these strong covalent bonds. So our answer is 1 and 2 are correct, which corresponds to D on the question paper.